Okay, for this video it says a cylinder contains 0.100 mole of an ideal monatomic gas. Initially the gas is at pressure of 1 times 10 to 5 Pa and occupies a volume of 2.50 times 10 to the negative 3 meters cubed. So I wrote down all the information, the pressure, the volume, and the moles, and also I wrote down the R, which is a constant, 8.314. So the part A for this problem says, find the initial temperature of the gas in kelvins. So I'm just going to write down this ideal gases formula, which is going to help us to find the temperature. So the formula is PV equals nRT, the initial temperature. So the initial temperature equals PV over nR. So I'm just going to copy the information from that we got in the formula. So it's 1 times 10 to the 5 times 2.50 times 10 to the negative 3, and that's over the 1.1 mole times 8.314, and that's going to give us the initial temperature, which is 300 Kelvin. So for part B, it says if the gas is allowed to expand to twice the initial volume, find the final temperature in kelvins to the gas if the expansion is isothermal. So for the so we have to do, we know the initial temperature is equal to final temperature. So we know the initial temperature is 300 Kelvin, so the final temperature is going to be 300 Kelvin. So that's the answer for part B. TF equals 300 Kelvin. I'll write it down again so you guys can see it. So for part C, it says find the final pressure of the gas in this process. So I'm going to use the final pressure versus final volume equal to initial pressure times final initial volume. So I just gotta solve for the final pressure. So I solve for the final pressure, which is final pressure equals P initial times B initial over B final. And now it says that the problem says that the volume final is twice the initial the initial volume. So I'm just gonna plug that in the formula. So P1 equal times PI over 2 times BI volume. So I'm just gonna cancel that out. So now I just have to plug it in the formula. So 1.0 times 10 to the 5, that is the pressure, divided by 2, and that's gonna give us 5.0 times 10 to the 4 pascals. So that's part C. For part D, it says if the gas is allowed to expand to twice the initial volume, find the final temperature in kelvins of the gas in the expansion is isobaric. So for part D, I'm going to use BF over TF equals volume initial over temperature initial. So I'm going to solve for the final temperature. So TF equals BF times Ti over Vi. So we know that the final volume equals to the B initial, 2 times B initial. So we're just going to plug that in. So 2 times Bi times Ti. So BI over BI, so we can cancel that, and then we just have to multiply 2 times 300 K, because that is our initial temperature. So that's gonna give us 600 Kelvin. Okay, for part E is asking to find the final pressure of the gas in this process. So we can use the final pressure is equal to the initial pressure. So that's going to be equal to the initial pressure, which is 1.0 times 10 to the 5 Pascal. And that's it. For that, now we have to find, it says part F, if the gas, sorry about that, if the gas is allowed to expand to twice the initial volume, find the final temperature in kelvins of the gas if the expansion is adiabatic. So for that, we have to use T final times P final y minus 1 equal to I Ti Pi y minus 1. So we have to find the final temperature. So now we're gonna solve for the final temperature, and that's gonna give us Vi over Bf times Ti. So we know that 2 times B initial is B final, so we can cancel a little bit right there. So we're gonna put Tf equals to Bi over Tpi y minus 1 times Ti. So we can cancel that, and then we're gonna end up with, now we have to find the y. So we know that y is equal to Cp over Cv. So Cp is equal to 3R over 2 plus R, and then we can add this together, so we're gonna end up with 5R over 3, sorry, and then we can solve for this, so this is gonna be equals 5R over 3 times 5 over 5R over 2, so we can cancel these R's, and then we can solve, and then it's gonna give us 5,3. That y is equal to 5,3. So I'm just gonna put it right here. Tf equals 1/2 of 5 over 3 minus 1 times the T initial, which is 300. And so the T final is gonna be equal to 190 Kelvin. So for part G, the last part, it says to find the final pressure of the gas in this process. So we're gonna use the PF final volume to the y equals to P1 B1 to the y. So now we're gonna solve for the final pressure. That's gonna be Pi over Bf, and then the y. So now we know that the initial volume, so we can do final volume is equal to 2 times B initial times the y. So we can cancel that, and now we have PF equals to PI 1/2 over 5 over 3, because it's the same y. So now we just have to plug the P initial that we know is 1 times 10 to the 5 times 1/2 to the 5 over 3, and that's gonna give us 3.14 times 10 to the 4 PA. And that's it.